All right. So today, like I was saying, we're learning about we're learning about right triangle trig word problems. And in right triangle trig word problems, they love to use two terms. They love to use something called the angle of elevation, and they love to use the angle of depression. So those are the two things we're focusing on here with these word problems. First, we're just quickly going to go over what angle of elevation is. Whenever it says there's an angle of elevation, what it means is the angle from the horizontal line. So here you can see there's a horizontal line. Can I zoom in? Yes. There's a horizontal line here. The angle going up from the horizontal is called your angle of elevation. Elevation is going up. So here, this angle is going upward to this line of sight. This is our angle of elevation. It's always starting from a horizontal line going upward. Always, always, always. So let's try, let me see. I don't want to pick the easiest one, but I don't want to pick the hardest one. Hmm, yeah, let's do this number 4. Because for some reason you guys always seem to have issues on kite problems. I don't know why. So let's go. It says Lana's kite is flying 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite is 48 degrees. I have no idea. I think this is a misprint. 48 degrees. If her hand is 5 feet from the ground, find the length of the string. So here on this problem, we know that Lana, now anytime you have any word problem, you should always, your first step should always be draw the picture. So I'm going to draw Lana, and I'm going to draw her string, her kite, and the string to the kite. And then it says Lana's kite is flying 60 feet above the ground. That's the height of the kite, which the height of the kite is always perpendicular. Height is always perpendicular with the ground. So that's a right angle there. Now, this problem is actually tricky. Why is this problem tricky? Does anyone know? Yes, Lana is 5 feet from the ground. So, what this means is I am going to draw another line that is 5 feet above the ground to complete my triangle. Now, what does that change? Lana is tall, or she's right. You're both right. Yes, this 60 feet, this height is no longer 60. Yes, the entire thing is 60. Let's erase this. The entire thing is 60, but from in our triangle that we're now dealing with, from her hand, 60 minus 5 is 55. What else, what other value do I need to put? There's one more thing that needs to go. Now, where do you think that angle of elevation is? Yes, the angle of elevation, it doesn't even really, you don't even really need to read the problem. All you need to know is there's an angle of elevation here, and it's going from a line that is the horizontal going upward. The only angle in this triangle that would be the angle of elevation is this angle down here because it's the only one going from the horizontal upward. But I mean, it even tells you, it says the angle of elevation from where her hand is holding the string to the top of the kite is 48 degrees. So that would be good. So now, what does it want us to know? The length of the string. So where's my x go? Yes, it's on the hypotenuse. So that is the length of the string. Now we have an angle, and we know one of the sides of a right triangle, and we're trying to find the second. We can't use Pythagorean theorem because we're missing two sides on a right triangle. We can't use Pythagorean theorem then. So we know we have to use trig here. First step to trig, label the triangle. 48 is our theta, 55 is our O, X is our H, and we don't have an A. So, which one, by SOHCAHTOA, which trig function am I using here? Oh yes, we gotta have trig. I think I'm assuming. Which trig function do we have to use here? Yeah, sine, right? We have O and H. That S tells us we're using sine of theta. Second letter is O, and third letter is H. Our theta here is 48. Our O is 55, and our H is X. What do we do to solve for X? Multiply both sides by X, yes. So if we multiply both sides by X, X goes over here. And what do we do to get the sine of 48 off of the X? Divide by sine of 48, yes. So remember I told you a little trick you can think in your head. Anytime your variable is in the denominator, you just switch what it's equal to with your variable. So X comes out front, and sine of 48 is now in the denominator. And then you just pull out your calculator. If it'll come up. There we go. So making sure our calculator's in degree mode, which mine is, great. 55 divided by sine of 48. And you get 74.01. What's our unit? Feet. Yes, we can divide. Are there any questions on this problem? The trickiest part about this problem was not the trig. The trickiest part was setting up the picture. Yes, go ahead. Is your calculator in degree mode? Yes, that is the number one. Anytime anyone's like, oh, I got a different answer, 99% of the time it's because your calculator is not in degree mode. Any other questions? How do you put in degree mode? Very good question. So you go to your calculator, and the mode button is right next to the second button. So you press mode right next to the second button. You go down to the third one, which says radian, and over to degree, and you press enter. And now it's in degree mode. And then to get out of it, you just hit second mode and it quits it. Any other questions? All right, so now we're going to skip down here to angle of depression. Angle of depression is the exact opposite of angle of elevation. Instead of going up from our horizontal line, we're going down from our horizontal line. So that means, so I'm going to put here, down from horizontal. Elevation is up, depression is down. Now, this picture is showing you that angle of depression and sometimes angle of elevation is a little bit more tricky. Because notice from our solid line in our right triangle, this horizontal solid line, there is no angle going down, meaning that my angle of depression here is actually from a line that we draw horizontally. So from this dotted line, that is a horizontal line, going downward to our line of sight is our angle of depression. Now notice here, I drew a horizontal line and on the bottom is a horizontal line. I'm going to draw these little symbols. If I know that angle of depression, I can't immediately solve using trig because that angle of depression is not inside of my right triangle. So what do I do to get it inside of my triangle? Why? Say the angle of theta. How do I make theta be inside of my right triangle? There's two ways you can technically do it. Why did I put these symbols here? What do these mean? No, this would mean they're the same length. Yes, arrows on lines mean they're parallel. Okay, what the heck does them being parallel matter to us? Yes, exactly. Because why? Why are these the same? Oh gosh, yes. Alternate interior angles. I totally stopped presenting. How do I go back and start presenting? Mm-hmm. Okay. So yes, they are alternate interior angles. And also, we just learned that this angle down here going up from the horizontal line is also termed the angle of elevation. So what this means is the angle of elevation equals the angle of depression. They're the same. They're going to be the same value. You just draw them in different. Elevation, yes. You can, yes, exactly. So now if it gives us the angle of depression is, say, 40, you can put that this angle of elevation here is also 40. All right, so let's try to do one. I don't think I'm going to do number 12 because that one is just a little too hard. I did it with my last class. Um, Let's do number 11. Let's see how number 11 is. So number 11 says, which I can't get it all on my screen. Oh well. It says wires attached from the top of a post to a point on the ground 24 feet from the base of the post. If the angle of depression from the top of the post to the point where the wire is attached to the ground is 61 degrees, find the length of the wire. Actually, I don't want to do 11 because that's almost exactly like the so I'll do 10. Henry is sitting in a tree 32 feet above the ground watching a deer. If the deer is 57 feet from the base of the tree, find the angle of depression from Henry to the deer. So Henry's sitting in a tree. I'm going to draw a line representing the tree, and I'm going to draw Henry on top of the tree. And it says he's watching a deer, so I'm going to draw a deer. And if the deer is 57 feet from the base of the tree, meaning that this length here is 57 feet. The deer is 57 feet away from the tree. And we know the height of that tree, or that line that I drew, represents the height of where Henry's sitting. Height is always perpendicular to the ground. So that's a 90-degree angle there. What else does it tell us? Find the angle of depression from Henry to, oh, there we go. That's the number I was missing. Sitting in a tree 32 feet above the ground. So Henry is 32 feet above the ground. And then it says, find the angle of depression from Henry to the deer. So where exactly do I put that X in our problem? Not quite. Where? Right. So you might get tempted here to put the angle you're trying to solve for here because it says, oh, angle of depression from Henry to the deer. So you're like, it's going down, but that theta I just drew is the angle going down from the hypotenuse. It's not from a line that is parallel to the horizontal. The angle of depression is actually here, going down from the horizontal, which we just learned this angle of depression is the same as the angle of elevation inside of our triangle because those are alternate interior angles. So what I'm actually solving for is this bottom right angle. So now that I know I'm solving for that angle inside of this triangle, I label my triangle as if I'm doing trig. So my opposite side is 32, my adjacent side is 57, and I'm not using my hypotenuse. So by SOHCAHTOA, which trig function am I using? Tangent, yes, TOA, O and A. So tan of theta, theta is what we're solving for, is O over A. O is 32, A is 57. How would you go about solving this? So you have to ask yourself, what are you trying to get by itself? Are you trying to get something in the fraction by itself? What are you solving for? The angle. What is currently attached to the angle? Yes, so that's what you think in your head. You're dividing by 10. However, you will never see a trig function doing division. Instead, what you'll see, and I'll give you a little hint. How could you rewrite this not as a fraction? I'll give you another hint. My circling not helping. What can I put as the exponent on this x to signify that technically it's in the denominator, but we don't want to write it in the denominator? Yes, to the negative 1 power, the inverse. So instead of dividing by tan here, what you can actually do is multiply both sides by the inverse of tangent, tan to the negative 1 power. Now this is technically dividing by tangent. You're just writing it a little differently. So tan divided by tan cancels. And on this left-hand side, you're left with theta. And on the right-hand side, it's tan negative 1 of 32 over 57. Anytime you're missing the angle, which I did record myself going over this last class, so the fact that everyone was silent means that you didn't go back and watch that recording. But the way that you solve for an angle always is by hitting the inverse on your function. So here we're using tangent. To get the inverse of tangent, you press second tan. And then you just do 32 divided by 57, enter, and you're done. 29.31 degrees, because it's an angle, and you're done. So the notes are always at the bottom of our Schoology page in the unit folders. So we're currently in unit 3. That means that you would open up unit 3, and last class was day 1 of unit 3, so you would open up day 1, and there'll be a video and also the key to the note there. All right, we're doing great on time. Uh-oh.